So in this video I will show you how to calculate this problem, a square root of 24 divided by a square root of 30 plus a square root of 6 to the power 24. Now the first thing I'm going to do is write this 24 as 6 times 4, and the same thing I'm going to do in the denominator. So we have a square root of 5 multiplied by 6 and a square root of 6. And of course that is to the power 24. I'm going to use in this spot right here the fact that a square root of a multiplied by b is equal to the square root of a multiplied by the square root of b. So I get that square root of 6 multiplied by the square root of 4 over square root of 5 multiplied by the square root of 6 plus the square root of 6, and all of that is going to the power of 24. I have in the denominator common factor this square root of 6, so I am going to take the square root of 6 in front of the bracket, and I am left with a square root of 5 plus 1. And of course that is going to the power 24. A square root of 6 can cancel out with the square root of 6, and then I get a square root of 4 that is only 2 divided by a square root of 5 plus 1, and that is going to the power of 24. What I can do at this point is rationalize the fraction. So I have 2 over the square root of 5 plus 1, and I am going to multiply that by the square root of 5 minus 1, and the square root of 5 minus 1, this fraction entire thing is 1, so nothing changes. So then I get 2 multiplied by the square root of 5 minus 1 over, and of course at this point I'm going to use the fact that a plus b multiplied by a minus b is equal to a squared minus b squared. What I get is the square root of 5 squared minus 1 squared, and that is just 2 square root of 5 minus 1 over square root of 5 squared is 5 minus 1. So I have 4 in the denominator, and of course in the numerator I have 2 square roots of 5 minus 1. 2 and 4 are going to cancel out, and I am left with 2 here, and that is square root of 5 minus 1 over 2. Of course, this is going to the power 24. The power of 24 remains over here. This goes to the power 24, and of course, this goes to the power of 24. Well, what I can do now is I can take this power of 24 and I can write 24 as 3 multiplied by 8. And then I can use the fact that 8 to the power m multiplied by n is equal to 8 to the power m, and then everything to the power n. So I'm going to use this fact, so I'm left with square root of 5 minus 1 over 2. That is going to be cubed, and then the entire thing is going to be raised to the power 8. At this point, well, I can use the fact that a minus b cubed is equal to a cubed minus b cubed minus 3ab, and in the brackets I have a minus b. So what I have then is a square root of 5 cubed minus 1 cubed minus 3 square roots of 5 multiplied by 1, and in the bracket I have a square root of 5 minus 1 over 2 cubed is going to be 8, and all of that is going to be raised to the 8th power. So the square root of 5 cubed is a square root of 5 multiplied by the square root of 5 multiplied by the square root of 5 minus 1 minus 3 square roots of 5, and in the bracket I have a square root of 5 minus 1 over 8, and that is going to be raised to the 8th power. So this is equal to square root of 5 multiplied by the square root of 5 is 5 square roots of 5 minus 1 minus 3 square root of 5 multiplied by the square root of 5 minus 3 square root of 5 multiplied by negative 1, so I get a plus sign here, and over 8. That is going to be raised to the 8th power, and then I have 5 square roots of 5 minus 1 minus square root of 5 multiplied by the square root of 5 is 5, multiplied by 3 is 15, and plus 3 square roots of 5 divided by 8 raised to the 8th power. So this is equal to 5 square root of 5 plus 3 square root of 5, that is 8 square roots of 5, minus 1 minus 15 minus 16 over 8 raised to the 8th power. I have 8 in common, so square root of 5 is what I'm left with, and this is negative 2, and I have over 8 raised to the 8th power. 8 and 8 are going to cancel out, and I have a square root of 5 minus 2 raised to the 8th power. And this step is very important because I can approach solving this problem in two different manners. So at this point, there are two main approaches that we can use to solve the problem. I will first show you the direct approach, which is calculating this term in front of us. The second approach I will show you in about 1 minute, and that approach is done by introducing the substitution. Solving this by that substitution is not an efficient method for this particular problem, but I insist on showing it because it is definitely a method you have to know, as it is going to become increasingly important and substantially more used in the future, and it is a method that will efficiently solve the problems which are going to be encountered. Now let's calculate this directly. What I have in the direct calculation is a square root of 5 minus 2, and I can write 8 as 2 multiplied by 4. Again, I'm going to use the rule that a to the power m multiplied by n is a to the power m, and then everything to the power n. So this is going to be the square root of 5 minus 2 squared, and that entire thing is going to be raised to the 4th power. So this is equal to the square root of 5 squared minus 2 multiplied by 2 square roots of 5 plus 2 squared is 4, and then the entire thing is going to be raised to the 4th power. This is equal to 5 minus 4 square roots of 5 plus 4 to the 4th power, and that is 9 minus 4 square roots of 5 to the 4th power. This is then equal to 9 minus 4 square roots of 5. 4 I can write as 2 multiplied by 2, and that is 9 minus 4 square roots of 5 squared, and then the entire thing squared again. So this is equal to 9 squared is 81 minus 2 times 4 square roots of 5 multiplied by 9 and plus 4 square roots of 5 squared, and then that is going to be squared. So I have 81 minus 72 square roots of 5 and plus 16 multiplied by 5, which is going to be 80, and that is squared. So I have 161 minus 72 square roots of 5 squared, and that is equal to 161 squared minus 2 multiplied by 161 multiplied by 72 roots of 5, and plus 72 squared roots of 5, and that is going to be squared. So this is equal 161 squared, that is 25,921, minus 2 multiplied by 161 multiplied by 72 is 23,184 square roots of 5, and plus 72 squared is 5,184 multiplied by the square root of 5 squared is 5. So this is equal to 25,921 minus 23,184 square roots of 5 plus 5,184 multiplied by 5 is 25,920. And then the final solution is 51,841 minus 23,184 square roots of 5. Let's return now to this circled in red, square root of 5 minus 2 to the power 8, because I want to show you at this point what the second method looks like. At this point, I'm going to introduce the substitution that x is equal to square root of 5 minus 2. What I know is that square root of 5 minus 2 is x, and I need that to the 8th power. So that is what I have to calculate, and that is equal to the square root of 5 minus 2 to the 8th power. What I have now from x is equal to the square root of 5 minus 2 is that x plus 2 is equal to the square root of 5. I can square this equation, so I get x plus 2 squared, which is equal to the square root of 5 squared, and then this is x plus 2 squared equal to 5. At this point, I am going to use that a plus b squared is equal to a squared plus 2ab plus b squared, and I get that x squared plus 4x plus 4 is equal to 5. So x squared is then equal to 5 minus 4x, which means that x squared is equal to 1 minus 4x. Again, I am going to square this because I need x to the power 8 and I only have 2. So I am going to raise this x squared to the second power, and this is 1 minus 4x squared. So I get x to the fourth power is equal to 1 minus 2 multiplied by 4, 8x, and plus 16x squared. Now, what is x squared? Well, I already have that x squared is equal to 1 minus 4x, and I'm going to use that fact at this point. So I have 1 minus x, 8x plus 16, 1 minus 4x. So x to the fourth power is equal to 1 minus 8x plus 16 minus 64x, as 4 multiplied by 16 is 64. So when we calculate this, we get that x to the fourth power is equal to 17 minus 72x. Remember, we need x to the 8th power, and we have only 4, so we are going to raise the entire equation to the second power again. So x to the 4th power squared is equal to 17 minus 72x squared. So x 2 multiplied by 4 is 8, and that is equal to 17 squared minus 2 multiplied by 17 multiplied by 72x plus 72x squared. So x to the 8th power is equal to 17 squared is 289 minus 2 multiplied by 17 multiplied by 72 is 2448x, and plus 72 squared is 5184x squared. x to the 8th power is then equal to 289 minus 2448x plus 5184, and x squared, we know that it is 1 minus 4x. So that is the fact which we are going to use now. X to the 8th power is then equal to 289 plus 5184 multiplied by 1, that is 5184 minus 5184 multiplied by 4, that is 20,736x, and minus we have here 2448x. So x to the 8th power is equal to 289 plus 5184, that is 5473, and we have minus 20,736x minus 2448x to be negative 23,184x. Now remember the substitution we have used. X is equal to the square root of 5 minus 2. I am going to return this fact into the equation which we have now. So x to the 8th power, x is square root of 5 minus 2, and that is raised to the 8th power. That is equal to 5,473 minus 23,184. And again, we encounter x. We know that that is a square root of 5 minus 2. So when we calculate this, we get 5,473 minus 23,184 square roots of 5, and plus 46,368. This is then equal to 51,841 minus 23,184 square roots of 5. And finally, we have a solution that a square root of 24 divided by a square root of 30 plus a square root of 6, entire fraction raised to the power of 24, is equal to 51,841 minus 23,184 square roots of 5. So thank you for watching. Please like, share and subscribe to the channel. And I suggest that you watch this video next.